So this program you have to find a given number as Amstrong or not. Amstrong number is, if it is an Amstrong number you have to return true, otherwise you have to return false. An Amstrong number is if there is a 3-digit number, if the sum of cube of all the digits, right, if it is equal to the original number, then it is an Amstrong number, right. This is, you have to do cube if it is a 3-digit number. Suppose if it is a 4-digit number, then sum of power 4 of all the numbers, all the digits, right. You get some value here, right. You get some value here. If this is equal to the original number, then this is an Amstrong number. Okay, so this is what is Amstrong number. Here they are in the question they have asked only for 3 digits. But when you think of a solution, you should not think of a solution only for 3 digits. You have to think of a solution for any number of digits, right? So what you have to do first, a simple how you think in your mind. First thing is, you have to find the count of the digits. Let's see what is the logic you need to follow. We'll see this later, right? When you code, we'll see it. Once you find the count of the digits, right? You got the count of digits. Then, suppose you have 3. Now, what you will do? How you will do in your mind? You will get this 3. Okay, extract the last digit, modulo 10, you get the last digit, right? Now, just in your mind, right? So, mind, let's allocate a variable for it. So, in your mind, extract this 3, power cube, and keep it in your mind. Okay, then extract this 5, power cube, and add it to this. Right now, the answer is there in your mind. Then extract this 2, power cube, and add it to this. Now your mind contains the complete value. Just return it. Right? This is a simple way you have to think. Okay. So this is the logic. Let's try to code it. So the first thing is, let's try to write functions for it. The first thing you have to write is to find the count of digits. So count of digits, output is also an integer. Count digits, input is also an integer, right? You have to find the count of digits. To find the count of digits, right, how many is there? One logic is, you just need to, right, keep a counter. Now how you will do it in your mind? In your mind, right, you have to keep a counter. You have to just keep on counting, right? First your mind will be 0. Now when you keep on divide by 10, right, the number of digits reduced by 1. When you divide by 10, it becomes 15. When you divide by 10, it becomes, when you divide this by 10, it becomes 15. Then you divide by 10, it becomes 1. Then you divide by 10, it becomes 0. So how many times it is allowing us to divide by 10? That many times you can keep on incrementing this counter, right, in your mind. So from here, right, when it comes before dividing by 10, increment the counter 1. Then again divide by 10, increment the counter 2. Again divide by 10. From here increment once, 2, and then 3. 3 times it will be incremented. One the n value is 0, we can return. So that's a simple thing we can do here. So have a counter. Whatever is there in your mind, you need to have a variable for it. Have a counter which will be initially 0. So why condition is you keep on divide by 10, right? Finally n will be 0. So n not equal to 0. First thing you have to keep on adding the counter. And n divide equal to 10. So for 153 you count once. Then for 15 you count twice. Then for 1 you count thrice. And when it becomes 0, come out of the loop. Return count. That's it. Okay. So we have written the count digits. So now first let's put a variable called cd. It's count digits. It is equal to, just call this function. It is going to return the number of digits. So you got the number of digits, right? Then what you have to do? You have to keep on extracting this variable, right? So we have to check whether it is equal to the original number, right? So let's have a variable original and let's store the n value here because we are going to change the n value. right, in the loop. So I store the original. So while n not equal to 0, what I'm going to do is I have to extract the last digit, correct? So I will have int digit. How will extract the last digit? N modulo 10. You get the last digit. Okay. So once you get the last digit, what you do is here in this logic. Now I have CD, which gives me 3. Now once I get the last digit, I will again in my memory, right? I should have 0 first. Then I get the last digit, I will cube it and add to this, right? I should have some variable, right? Initially it should be 0. So I will have a variable sum, which is initially 0. Now in my mind I have to add to it, correct? I have to add to this sum. What I have to add? What digit I have got, right? Let's the 3 power how many number of digits, right? That is what I have to add. So I will have a power function digit comma power your count number of digits. What I have to add? Digit is what is 3. 3 power 3 I have to do first, and then I have to add to the sum. I have to add to 0, and I have to store it in the sum itself. So next time when it comes, then what I will do is, so I have taken 3, right? Now I have to remove 3. So n divide equal to 10, 3 will be gone. Next becomes 15, right? The 3 is gone. You have added 3 to this. Now it becomes 15. Now again 15 comes, n modulo 10 will be the last digit 5. Okay. So 3 power 3 is what? 9 into 3 is 27, right? Now sum must be 27. So 27, this is what is? This is nothing but 27, right? 27 plus power of digit comma CD. What is digit? Digit is the last is 5. Power of 5 comma CD. CD is count of digit 3, right? Which is what? 5 power 3. This function we have to write. This is what it is 5 power 3. That I am adding to sum. Sum is already 27. I am adding to the sum and storing in the sum. Now sum we have got this. Now n divided by 10, it becomes 1. N is not equal to 0. N modulo 10 is digit will be 1. So 1 power 3 I will add into sum. This is sum. The 1 power 3 is added to sum. Now I get everything in this sum. N modulo n divided by 10, 1 divided by 10 becomes 0. Now it comes out of the loop. Okay. Now when it comes out of the loop, what I need to check? My sum contains this complete sum. If it is equal to the original number, then it is an Amstrong number. You have to return true, else I have to return false. Right? It's so simple. So the only thing left here is, right, we have to do the power of the digits, right? So let's write a function for it. So int power, it has 2 arguments, right? One is the digit, that's also an integer. I put it as d. Now other integer will be number of digits, right? Let's have it power of a comma b, right? What this function has to do? This function has to return a power b, right? So suppose if you pass 5 and 3, it has to return 5 power 3, which is nothing but 5 into 5 into 5. That is the logic we have to write here. Now how to do it? Again in your mind, right, keep 1, right? So this number, right, a, just keep on multiplying by this. Multiply it once, it becomes 5. Then multiply it again by 5, it becomes 25. Again multiply by it. How many times you have to do? We have to do it 3 times. So in your mind, just keep 1 initially, then keep on multiplying 5 with it to find the power. So in your mind, what you are keeping? Power value is 1. So until how many times you have to do? You have to do it b times, right? Power b, right? So for int I is equal to 1, I less than or equal to b. That many times you have to do, right? I plus plus. That many times what I have to do? I just need to multiply power with a. Keep on multiplying it. So first power is 1, right? Multiply 5. 5 into 1 is 5. Next time 5 into 5. Next time. Okay. So let's do this and see. When I is equal to 1, you get p becomes 1 into 5. 5. When I is 2, right? Now b value is 3. Right? When I is 2, 5 into 5. Again 25. When I value is 3, again this into 5. When I value is 4, 4 less than or equal to 3, this is false, comes out of the loop. Just need to return the power. Okay. Just return this p. Right? That's it. Looks like our stuff is done. So similarly here, right? Similarly, a part of a logic, put it in a separate function. This logic finds the counts of digits, and then this logic finds the power of digits. And we have just calculated this, check with the original, and then return true or false. Let's compile and run and see any issues here. So one issue here is, this is a static function. We will see what is static clearly. From a static function, we have to call only static function. So all these functions should be static. See, non-static power cannot be referenced from static context. So in this case, in Geek for Geek, suppose this function is static, you have to put the other function also as static. We will see static clearly when we see classes and objects. Great, all the test cases are passed.